Hey guys, this is Mrs. Tran-Bloom. I'm a little sick, so I'm actually, I feel like I sound funny. So if I sound funny, just because I'm kind of losing my voice. And I'm drinking green tea with honey, so if you hear a little funny sound, that's just me drinking my green tea. Alright, so here we go. 6.4. We are now studying the graphs of sine and cosine functions. So let's just kind of remind ourselves of the six trig functions. F of x equals y, sine of x, okay. F of x equals y, which is cosine of x, and y equals tangent of x. So these are the three main ones, and then we're going to do the reciprocal of 1 over sine is going to be cosecant of x. Reciprocal of cosine is going to be secant of x. Reciprocal of tangent is going to be cotangent of x. So these are the six trig functions that we're going to learn how to graph as we go in this chapter. So let's talk about the two definitions here. Definition period or cycle. Okay, so period or cycle, some books will use period and some books will use cycle, but it means exactly the same thing. It is the distance required for the function to complete one full cycle. Okay, so because it's a distance, we're going to talk about absolute value. Okay, so the period, it's given to you as 2 pi, which is a full revolution, divided by absolute value of b. Okay, and let's talk about, okay, so for example, y equals sine of, let's do 3 sine of 4x, okay, just randomly. So this is your a value and this is your b value. So in this case, your period or cycle, it's absolute value 2 pi divided by 4, which is going to be absolute value of 4. So we're going to end up with a pi over 2. Okay, so instead of completing a full cycle over 2 full periods, it's going to complete a cycle in a half, a pi over 2, which is 90 degrees. Okay, so a quarter of a revolution. Now amplitude is the height from the mean, or the height from the middle. Okay, so amplitude is the height from the mean, which is in the middle. Okay, so it's kind of like the average height. So why is the amplitude important? The amplitude and periods are important in the study of music. So for example, amplitude indicates the energy or the loudness of a sound, and the period determines its pitch, okay, the frequency. So that's why amplitude and period are really important. Now, because the amplitude is the height, so we're going to talk about absolute value as well. So the equation is going to be absolute value of A. Well, if this is B, this is A. So for our example that I just wrote in there, my amplitude is going to be absolute value of 3, which is 3 units. This is 3 units from the center. So 3 units up, 3 units down. Okay? So now we're going to go to the graphing piece. So this is the parent function. Y equals f of x equals sine of x, because y and f of x are exactly the same. Okay, so let's find the period and amplitude. Excuse me. So my period, from the definition above, okay, is 2 pi divided by the absolute value of b. So 2 pi divided by absolute value of b, which is 2 pi divided by, okay, b is located behind the word sine, and a is located in front of sine. They both happen to be 1. So 2 pi divided by 1 is 2 pi. So this parent function is going to graph itself a full cycle, okay, with 2 pi. Now let's find the amplitude. Okay. Amplitude is absolute value of a. So because this is 1 times sine of x, so it's just going to be absolute value of 1, which is 1. Now all parent functions will always have, for sine and cosine, will be 2 pi and 1. Okay, 2 pi for the period, amplitude is 1. So what I'm going to do is I'm going to graph out 3 full periods. Okay, so I'm going to go, because each period is 2 pi, so this is 2 pi. That's 1 period. 2 periods is 4 pi. And then I'm going to do a negative period, which is negative 2 pi. And because my amplitude is 1, I'm going to go as high as 1 and as low as 1, because it's an absolute value, or it's the height from the center. So from here, what I'm going to do is I'm going to make a table. Okay, so here's my table. This is going to be my input. This is going to be my output. Okay. Now at this point, I do expect you to know the unit circle very well. Okay, so I'm going to pick values. Okay, so here's the unit circle. I'm going to pick when the angle is 0. When x is 0, sine of 0, because this is 1 comma 0, sine of 0 is 0. Okay, then I'm going to pick easy values. I can pick 30 degrees and 45 degrees and 60 degrees. But, okay, so let's just pick this value right here, 45 degrees, pi over 4, which, by the way, when you're graphing, only use radians, alright? When x is pi over 4, sine of pi over 4 is rad 2 over 2, okay? And so we're going to go with this piece. This is 90 degrees, or pi over 2. Pi over 2, this is going to be sine of pi over 2 is going to be 1. Then we're going to pick this point. Okay, this is 3 pi over 4, so sine of 3 pi over 4 is going to be positive again, rad 2 over 2. Then I'm going to pick this point, which is a pi. Sine of pi is going to be 0. Then I'm pick this point, 5 pi over 4, which is negative rad 2 over 2. Okay. Then I'm going to pick this point, 3 pi over 2. Then if I pick 3 pi over 2, sine of that is negative 1. I just have 2 more values. Pick this point, 7 pi over 4, which is a negative rad 2 over 2. And my last point is going to be, I'm out of space, I'm just right here. Back to 2 pi. Sine of 2 pi, x and y. Sine of 2 pi, it's back at 0. Okay, so check out the points that I have. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 points. Okay, so let's plot this out. So what I would like for you to do is start with finding out the period and amplitude and label those. Now, if I want to graph 3 periods, I'm going to go 1 period, 2 period, which is double that, and then a negative. Now, if this is 2 pi, right in the middle, it's obviously pi. Okay. Now, if that's from here to here's pi, this is now would be a pi over 2. Okay, so I'm going to do every period, you need to have 4 different intervals in between. Okay, so, and then this is going to be 3 pi. If that's 3 pi, make 4 intervals. Here we go. And each interval is worth a pi over 2. So that's 1 pi over 2, add another pi over 2 is pi, add another pi is going to be 3 pi over 2. Similarly to the negative. Okay, make 4 intervals for each period. Okay, now the unit for each tick mark, it has to be identical. You can't label this a pi over 2 and all of a sudden the next tick mark is 3 pi over 2, because then that's a distance of pi over 2 and that's a distance of a pi. So you need to be consistent. Okay, so now that I have it all labeled, we are going to graph this out. So when x is 0, y is 0. So here's my dot. When x is pi over 4, I don't have it on my tick mark. Okay, but that doesn't mean I don't know where it's at. Pi over 4 is in between, exactly in between between 0 and pi over 2. Now, rad 2 over 2, if I take my calculator, let me just show you what rad 2 over 2 is. So rad 2 over 2, radical 2 divided by 2. It's about ooh, that's really glaring. It's about 0.71. Okay, so I know it's under 1. So 0.71, right in the middle, 0.71. There you go. Then I'm back at pi over 2, which is perfectly at 1. At 3 pi over 4, which is in between pi over 2 and pi. Again, we know rad 2 over 2, which is right here, it's 0.71, which is this dot. I'm going to use red. Okay. I'm using red for the approximation. And then pi, I'm going to go perfectly at 0. At 5 pi over 4, which is again, the pattern continues. If those red dots are in between two tick marks, then I know 5 pi over 4 is also in between two tick marks, and I know I need to go a 5 pi over 4. What on earth is that? 5 over 4, 3. I'm sorry, this is a negative right here. Can you fix that for me? This is a negative. Okay. So 5 pi over 4 is going to be negative 0.71, which is right here. Okay. All my red dots are approximation. Okay. 3 pi over 2, which is this dot, I'm going to go negative 1. Then 7 pi over 4, which is moving up a little bit, negative rad 2 over 2, which is a negative 0.71. And I'm back at 2 pi, which is now at 0. So check those dots. Okay, so I'm going to connect those. Okay, so that's one full period. Okay, now what happens if I graph the next period? Then it's going to repeat itself. Okay, so the period is, hey, what's the distance that you have to go before it repeats? Okay, so I'm not going to make a table anymore, guys, because every period this is going to repeat itself. This is why trig is periodic, because it's going to repeat itself. So if my first tick mark it's at 0 and my last tick mark it's at 0, I'm confident that my one tick mark to the right of that, I'm going to go up 1. So one tick mark on that, I'm going to go up 1. 2 tick marks of that, I'm saying it 0. 3 tick marks of the beginning, I'm going to go negative 1. And then obviously I'm back at 0. So this is repeating itself. Okay. Now how come I didn't plot my pi over 4 or multiples of pi over 4? Because I don't need to. Okay, so when you're graphing it out, I want and only need the main ones, which there are 5 of these. Okay, so I would only need you or require you to make points or label points for those 5 main ones. Okay, with the approximation, I was just doing it to just show you that it's on the graph. I just don't need you to use those points. Okay, how would I repeat this cycle on the left? So if you look at this, okay, I'm starting at 0, which is this piece. So if I take this and copy it over, okay, so this is my 0, which is here. If I go 1 on the left, I'm going down negative 1. So go on 1 on the left, negative 1. Go 1 on the right, staying at 0. I'm sorry, 2 on the right. And then 3 on the right, go up 1. Then we're going to go down and staying at 0. So if you were to repeat this, this is what it's supposed to look like. Okay. All right. Arrows on the two ends. Okay. Because we're stopping at 3 cycles doesn't mean that the sine function stops at 3 cycles. Okay. So now that's a perfect sine wave. So let's talk about the properties of sine function. If you check out the domain, it's going to continuously go on forever. So this is going to be from negative infinity to infinity. The range, if you check out the height, right, you have negative 1 and to positive 1 inclusive. Symmetry, okay? What is it symmetric about? It's symmetric about the origin. Okay, so if I pick a point in quad 1, there should be a point in quad number 3. If I pick a point in quad 4, there should be a point in quad 2. So this is origin. Period, we found it earlier. The period is 2 pi. Do we have any x-intercept? Sure we do. So if you check out the x-intercept, we have 1 at 0, 1 at pi, 1 at 2 pi, 1 at 3 pi, 1 at 4 pi, and so on and so on. So how would we write that? Intercept is going to be a pi k, okay, comma 0, where k is any integer. Okay, so we have to define this k value. Where's your y-intercept? Your y-intercept, there's only one at 0, 0. What's the maximum? The maximum, it's at 1. Okay, so the maximum is when x equals to, actually, the maximum is just going to be 1. And the minimum is going to be negative 1. And we can talk about where x is at these points. Okay, so the maximum is 1, where x is at pi over 2. And then we have this one is 5 pi. This is a 2 pi. If you add another pi over 2, that's going to be 2.5, which is really 5 pi over 2. Okay. So if you check out the difference, the maximum, it's pretty much 2 pi over. So another, and then over here, if we subtract 2 pi, we're going to end up at a negative 3 pi over 2. Okay, so we can always talk about the multiples, okay, the addition and subtraction from pi over 2. So when x is at pi over 2 plus or minus 2 pi, okay, and then the minimum, it's 2 pi k, because we can do, well, k is pretty much any integer, okay. And then the minimum, it's going to be at, we have a negative 1 here for y, and this is a pi over 2, this is a pi, so this is 3 pi over 2. The next minimum is going to be at 7 pi over 2. Okay, so similarly, we're going to add 2 pi again, but the first one is going to be at 3 pi over 2, where x is at 3 pi over 2 plus or minus 2 pi k, where k is any integer again. Okay, so that's the sine function for this piece. Alright, let's go on to cosine. And pretty much that's my last example of this video. Okay, so cosine, it's going to ask you to graph again. So we're going to find its period and amplitude. So m, its absolute value of a. Well, since this is 1 times cosine of x, so there's 1 in the front, so this is an amplitude of 1. That means my most is 1 and my lowest is 1. Period. Okay, let's write the equation out for now. 2 pi divided by absolute value of b. This is 1x, so we're going to have 2 pi divided by 1, which is 2 pi. So my amplitude, my period. So if I ask you to graph 2 full cycles, we're going to have 1 cycle on the right, 2 cycles on the right, which is 4 pi, and then a negative cycle on the left. Okay. Now earlier I said we didn't have to use the approximation one, so I'm just going to make a table of those 5 main one, and these are the 5 main one that you're always going to pick. Okay, when x is 0, when x is pi over 2, when x is pi, when x is 3 pi over 2, and when x is 2 pi. Now if you look at the circle, these are the quadrant angles, right? Okay, this is 1 comma 0, this is going to be 0 comma 1, negative 1 comma 0, and this is at 0 comma negative 1. So when x is 0, I'm going to put that into the input. Cosine of 0 is going to be 1. When x is pi over 2, cosine of pi over 2 is 0. When x is pi, cosine of pi is negative 1. When x is 3 pi over 2, cosine 3 pi over 2 is 0. When x is back at 2 pi, I'm going to have 1. Okay, so those are my input and my output based on the unit circle. So let's plot those 5 points. You're always going to need 5 points for each cycle. Alright? So 0 comma 1, there's my dot. Pi over 2. Right now I don't have 4 intervals labeled, so I should go and do that. This is a pi. That's pi over 2. And that's 3 pi over 2. Go in the middle, do 3 pi. There's another one. There's another one. Go in the middle, do a negative pi. So every interval, for every period, you need 4 intervals, okay? So pi over 2 is right in between 0 and pi. Make a dot. Pi is going to be negative 1, so here's pi, go down to negative 1. 3 pi over 2, staying at 0. 2 pi, going up at 1. So here is a curve, okay? So now if I were to repeat this, where would I plot the rest of my dots? Okay, so my dot started at 0 comma 1 and it ended at 0 comma 1. So if I go, so here's my starting point. So I have a dot already. So if I were to repeat, I would go to 1 to the right and staying at 0. I would go 2 to the right and go down negative 1. I would go 3 to the right and staying at 0. I would go 4 to the right and go back at 1. Okay, similarly to the left. Right now I have a dot on the top, so I'll pick a dot on the top, go 1 to the left, that means I'm staying at 0. 2 to the left, so 2 to the left, go down -1. 3 to the left, that means I'm staying at 0. 4 to the left, I'm going back at 1. So this is the dots. Connect the dots. Now on the bottom here in the top, make sure you round it out. Okay. To make an arrow, because I'm already at my max, so I have to loop back down to make an arrow, similar to over here. Because I'm already at my top, I gotta go loop back down to make an arrow. Do not make an arrow to continue going up, because that would be incorrect. Okay. So now we're just gonna go fill out our properties of cosine function. So the domain is very similar to the sine function, which is all reals, -infinity to infinity. The range is identical to the sine, -1 to 1. It's symmetrical about no longer the origin, but if I were to fold it along the y-axis, it would be the same on the left and right. The symmetrical about the y-axis. This is also even called even, right? Period, we found it earlier at 2 pi. Okay. X-intercept looks like there's 1 at pi over 2, 3 pi over 2, 5 pi over 2. So we're going to say that it's pi over 2. Okay, so let's think about the pattern. First one's pi over 2, then we got 3 pi over 2, then we have 5 pi over 2, okay? And then over here, if you look at this, this is -pi over 2. So what is the pattern right here? What do you think this is? How would I go from one to the next? What would you have to do? Would you have to add, or would you have to multiply? Can I multiply to get to the next one? So this is 1, 3, and 5. So can I say that is going to be pi k when k is an odd integer? Okay, so we can say that. So this is pi k. If k is 1, I have 1 over 2, which works. When k is 3, which is an odd integer, 3 over 2, that works. When k is 5, 5 over 2, that works. When k is negative, so where k is an odd integer. Okay? So you always have to define what your k is, otherwise it doesn't make sense, because earlier we said k was all integers. Okay? Y-intercept, we have 1 at, I'm sorry, that's not y-intercept, x-intercept. Y-intercept, there's only 1, 0, 1. We have a maximum at 1, okay, when y is 1, and we have a minimum when y is -1. Now, if you want to look further to see where x are at, so max is at 1 when x is 0, max is at 2 pi, and max at 4 pi. So what's the pattern? We're always going to look for the pattern, okay? So this is for the max. You have when x is 0, when x is 2 pi, when x is 4 pi. So max is at 1 when x is what? 2 pi k, when k is all even integer. Okay, so max is at 2 pi k, where k is all even integers. Okay, how about minimum? Minimum when x is at, let's check it out. We have a pi, we have 3 pi, we have -pi. Okay, so we have -pi, we have a pi, we have 3 pi. So if I have to make an educated guess, I would add or subtract 2 pi. That will also work. 2 pi k, okay, and then, or we can write, hey, if I write it as x is at, when x is at, let's say, pi k, where k is, this is 1 pi, 3 pi odd, okay, any odd integer. Okay, that will also work. Sorry, this is kind of getting really small. I just don't want to fit in it. So if I were you, I would just list out all the obvious x values that we have here, and then see a pattern. All right. All right. This is about 25 minutes. Sorry for such a long set of notes. with that said, I'm just going to give you our joke of a toddler joke of the day. What day of the week do fish hate? What day of the week do fish hate? Friday. Fish hate Friday. We love Friday, right? But they hate Friday. All right, have a good day, and I'll see you guys next time.